Okay, so welcome back. How many of you were in my first talk about an hour ago or 45 minutes ago? You poor, poor bastards. Well, welcome back. We're going to talk about building microservices. Actually, what would be more appropriate is to talk about building cloud-native. We're going to build cloud-native applications, of which half has to do with microservices. My name is Josh Long. It's up there. If you have questions, email, feedback, etc., I'm happy to hear it. Also, please, qa.devox.pl, send questions. I'm happy to have them. You must have some questions. I have questions, and I was paying attention. So, come on out and say hi. I think that's it. There's going to be, yeah, good. Okay. So, right, my email, my Twitter handle. Code is up there if you want to see roughly what we're going to be doing. What I'm going to be doing is we're going to look at how to use Spring Cloud, which builds on top of Spring Boot, to build microservices. We're going to go pretty fast, and we're going to cover just a small fraction of the possible things you can do. Again, my amazing slides, which I worked very hard on, are online. So if you want those are there. I am, as I said before, Josh Long. I'm a contributor to Spring Boot, Spring Cloud, Spring Integration, Vaadin, Activity, blah, 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 blah. My books these days tend to focus on Boot and Spring Cloud and Cloud Foundry. These are technologies that are used to enable agile development, to enable building applications that work well in the cloud. And I work for a company called Pivotal. Pivotal's where Spring lives these days. Now, these technologies that you see on this, wow, that's a bright light. Can we turn that on? Yeah. The technologies that we see on that slide today are technologies that we hope will make it easier for developers to build applications and get to production quickly. Right? It's all about reducing that time between having a concept and getting it into production, into customers' hands as quickly as possible. Today, we see a lot of people moving to the wide world of microservices. How many of you have heard of microservices? Microservices? Okay, so it's an architectural style, right? And there's a lot of different reasons that people move to this architecture. The principal one is, I think, Conway's Law. It's this idea, oh, are you okay, my friend? Oh, my. It's this idea that software is a reflection of the organizational structure that it serves. I've heard this alternatively stated as, if I have two different teams working on a compiler, invariably my compiler will be a two-pass compiler. If you think about modern websites that we know about today, like Netflix, like Amazon, how many of you know what Netflix is? Netflix? They're a streaming video service, okay? And they do TV shows and movies and so on. On the internet, as a concept, in terms of streaming video, there is pornography, then Netflix, then, by less than half, YouTube, okay? So Netflix is huge. It's crazy. I mean, that list is pretty ridiculous, right? Netflix has succeeded because they made it very easy to be agile, to be able to move as fast as possible. They said they have different business functions, and they need to be able to deploy software continuously and see that that software grows as fast as possible. So they broke apart their code and made them into smaller, singularly focused services. These services move at the speed of each vertical in the business. And of course, this brings other benefits. For example, it's easier to scale these kinds of services because you can just copy the service and start them up. You don't have to, scale out a co-located monolithic application. It also meant that they could use the right technology for the job. I've heard, but nobody's ever confirmed it. This is just a thing that I've heard on the streets, that there are other technologies besides Java and Spring. Now, again, nobody's ever proven it. Can't be proven. But maybe there are, and maybe in some case, you might want to actually use those technologies, right? Specifically, when we talk about persistence and data, again, being able to choose the right technology for the job is very important. So, Netflix moved to this microservice architecture. They created when we talk about the cloud-native architecture, we're actually talking about two different things, scaling your services and scaling your data. And we're going to talk about scaling your services today specifically. That's microservices, okay? It introduces complexity, and so we're gonna start from the beginning at start.spring.io, just like we did last time, okay? Goodbye to this. And we're gonna spend some time today looking at this section of the start.spring.io, the cloud section. So I'm going to do what I did last time. I'm going to build a quick application called the Reservation Service, same as before, JPA, H2, actuator, great. I'm going to hit generate. Oops, I'm going to rename this actually. I'm going to call this Reservation Service, and I'm going to hit generate, and this is going to give me my first REST API. We're going to re-implement it because I mistakenly threw away the code from my, from my last talk. Here we are. Goodbye. Oops. Good, and I'm going to open this up, and we're going to write a quick REST service, and then we're going to build infrastructure to support cross-cutting concerns involved in scaling out, involved in adding more services. Again, people are scared of the microservice architecture because they fear that the friction, the complexity involved in having lots of moving parts is going to prohibit them from moving quickly. And that's actually quite the contrary. It is worth stating, however, that you may be better off starting with what we call a monolithic application and use that as a chance to discover the boundaries between your modules, your components. So we're going to start with, for a demo, of course, I'm going to start with a microservices first approach. I'm going to go here, and we're going to do the same thing as we did last time. I'm going to say class reservation, and it'll just be at ID, at generated value. And again, I hope you saw my talk on Spring Boot, but we are using Spring Boot here. So a lot of the noise that we have to worry about when we build services just goes away. And now we can focus on the business concern, okay? I'm going to say at entity, great, like so. And I'll build an repository, reservation repository, extends JPA repository, reservation, like that. And I'll say, okay. And I'll say that I want to create some dummy data, okay? So we'll have some records in the database. And the way I'm going to do it is I'm going to create a bean of type command line runner, and the command line runner will get started when Spring Boot starts up. There it is there again, right? And all I'm going to do is I'm going to say arrays.asList. Good. Bob, I don't know, I got nothing. Names for each n, for each one. Save, new reservation, okay? There we go. Pass in the right name, Josh. Okay, and then of course this is Java, so I'm going to create some stuff for Java, just for Java. Love you, Java. Okay. I need a toString, naturally. So, okay, we should now have an application that is going to start up. It'll have 5 records in the database. We're going to print all the records that we get back. We're going to say, for each one that comes back, print out the information. Fabulous. Now let's start this up and see what we get, just to confirm that everything's working. And then we'll start to introduce a client. And in order to support the client, and again, this is just one service calling another service, but in order to support that, you'll see that there are some cross-cutting concerns that are also non-functional requirements. These are things that you need to promote healthy, resilient services, but that aren't particularly fun. So Spring tries to make them as easy as possible to get done and out of the way as quickly as possible. So what did we do wrong here? Did I create I haven't created a REST endpoint. So we're going to build a REST controller class, reservation REST controller. And we're going to say request mapping, and it's going to stand up and just expose the data in as simple a format as possible, okay? Like that. I'm going to say return this dot, and I'll say at autowired reservation repository, like so. And there we are. Good. And we're going to restart again, okay? So we'll see this endpoint now serving traffic and serving all the information from the reservations endpoint. Awkward. Good. Here we are. Refresh. There's our data. Now, when we talk about building microservices, the first cross-cutting concern, the first non-functional requirement that becomes very important when you start adding more services is configuration, I find. Configuration, in this case, refers not to the wiring of objects, but instead to what we call 12-factor app style configuration. The database passwords, the locators, all these things that change from one environment to another. You saw on the last, as we looked at this in the last talk, that you can easily run a Spring Boot app, and if you go to the desktop here, like so, and you say reservation service, and then you do Maven, D, skip tests, SQL, clean install. You saw that it's very easy for me to build the code and then run it as a jar. That's what I've got here after all. And I can do java -jar demo generated, whatever, reservation service. And if I want to override the properties, for example, the database and the host and port, of course I can go to application.properties, and I can say server port, or I can say spring.datasource.url, and all that stuff, or I can say server.ssl, for example. All this stuff is stuff that it's very interesting and very, very powerful to be able to configure from application.properties. But I could also use application.yaml, YML, okay? So in that case, it would have been server, port, like that, blah, blah, blah. Or if I want, I can keep that configuration outside of the process. I can say -d server port equals 8010, and that overrides the property in the property file in the jar. Same thing if I have a touch application.yaml, blah, blah, blah. If I start the application up and application.yaml or application.properties are in the same directory, those values will override what's in the jar. Also, I can do this. I can say export server underscore port, equals whatever, right? 8030, and that'll override server.port inside the configuration. So this is very convenient, but again, if you start adding lots of instances and lots of services, it's going to get painful to have to manage this configuration each time. There are a couple of things that we don't have good support for here. First of all, what about encrypted passwords? A lot of regulatory environments require that you have, when doing you have to do at-rest encryption, which is to say that passwords stored in the file system should be encrypted, and then only in flight, between when the code is loaded and when it's actually used to create the connection, should it be decrypted, right? That's a very important thing. Second of all, I want traceability. I want to be able to see, oh yeah, some guy didn't just log into production drunk and make a change and then break things, right? I want to see who made changes. I want to see when it was made. And I want to see what he changed and what she changed, and be able to roll it back if I need to, right? The other thing is that if I have a lot of services, and that is after all the goal, right? As you build larger and larger apps, you should create more services. It's easier that way, right? As I have more services, I want to be able to change configuration centrally. So you have a lot of different requirements, all of which kind of come together, and we're going to talk about a solution. It's called the Spring Cloud Config Server. So we're going to go back to Spring Initializer here, and for my first trick, we're going to say config service, and then I'm going to go here and I'm going to say, give me the config server, okay? So that's this thing right here. And I don't need H2, don't need JPA, and I'm going to hit generate. And that's going to give me a little jar. And again, I could do what I'm doing in Java here using the Groovy CLI. You'll no doubt remember from the last talk that it's very, very convenient to build all of this stuff using Groovy. So I'm going to do it from Java, but just keep in mind that you could do it from the Spring Boot CLI as well, and it's actually markedly smaller. My friend Peter is going to have a talk later this week about how to use these services in a cloud environment, in particular Pivotal Cloud Foundry. So you'll see that it's even easier to stand this stuff up. You don't actually have to write this. Every time you build a new service, you have to get this recipe right once. Get it right once and then reuse it. You'll never have to worry about this again. I'm showing it to you now so that we understand what's happening. So here's the Spring Cloud Config Server. In order to use it, I need to do some configuration. I need to tell it, great, your name, the application name is called config service, okay? I need to tell it to talk to a config server. A repository of configuration information. Remember the requirements. We want traceability. We want to see who made changes to what. We want to be able to roll back. Well, it turns out that Git is actually very, very good at that, right? So what I'm going to do is I'm going to point it to a desktop, a local repository on my file system, but it could be an HTTP GitHub URL or GitLab or whatever, and I'm going to say use this Git repository on my desktop in my config repo folder. That configuration lives here, right? So cd config repo, and you can see I'm going to do git init, great, git status, git add, and I've got a few files here, but you're going to see that even if I cat all of the files, I have these pretty silly few lines of configuration. I don't really need the configuration. I just want to be able to demo some stuff, so I had to create some values just to show you that we could, okay? So I'm going to do git add, git commit, and what this is going to do is it's going to stand up a proxy, sort of an intermediate service called the config service that will talk to the configuration files that live in this Git repository. All my other microservices will talk to the config server proxy, and they'll get their configuration from that. So this config server proxy thing can do decryption, it can do It can do password protection and all that stuff, and it has the ability to centrally change things live. I can actually change things in my configuration and then trigger the change in my applications as they're running without having to restart centrally, right? This is very, very powerful. So we've done that. What else do we need? I think that'll do. Again, this is the code. I need to actually write some code, of course. So there's my code. You're welcome. And I want to tell the config server to run on port 8888. That way my other services will connect to localhost :8888, and they'll find this service, okay? Good, let's see. Go back to this, Command-Alt-D, demo application. Oh. And while that's coming up, we're going to teach our reservation service how to get its configuration from here. So first thing we're going to do is we're going to bring in this dependency from the Maven POM. It's called the Spring Cloud Starter Parent, and it's how we can find all of the dependencies for Spring Cloud, which again, very much like the Spring Boot Starter Parent, is managed for us by this dependency. You don't have to worry about getting the right versions and all that stuff. You just bring in the dependency, and it'll just work. So we're going to say Spring Cloud config client, okay? And I don't need to worry about the version. Thank you. And then I'm going to tell my code, I'm going to tell my reservation service that it needs to have a name as well. So it's going to be called Spring Application Name Reservation Service. And this name is very important. We're going to use this name over and over for a lot of different things. The first thing that we're going to see is that it's going to be used to load configuration, right? So there's reservation service.properties or reservation service.yaml, whatever it is, Those configuration values are what this microservice wants to use. That's how that's what it's going to need to connect to that. The next thing we want to do is say Spring Cloud config URI is HTTP localhost 8888. Now, of course, I could do something like this. I could say config server like that, and that's an environment variable, right? And that'll say use this environment variable, or if it's not available, do that. But for our purposes, let's just keep it simple so we can keep track of what's happening. And this information is the only kind of configuration you're going to have in your different microservices. Everything else will be loaded from the config server itself. Because this is configuration that gets loaded before the other configuration, we need to put it in the bootstrap phase. So we're going to rename this file to bootstrap.properties. And indeed, that's what most of our services are going to do, is they're just going to have bootstrap.properties and so on. So remember, by default, Spring Boot is going to start this application up on port 8080, right? And if you see what we've got here, cat reservation service, it says server port is going to be 8000. So we're going to run this application on 8000 now, right? It's getting its configuration information, not from my local jar or anything in there, but it's getting it from the config server. You can see what the config server is giving us by going to the REST API that it provides. So 888, and I can say reservation service master, okay? And there's the information. It's saying, okay, I'm going to get the configuration specifically for this microservice called reservation service from this config file. It's going to get message and server.port. And then all microservices will get their configuration from application.properties. Now, application.properties is generic. Every microservice will get the configuration in that application.properties file. Only the service that identifies itself as reservation service will get this configuration. So in this case, server.port 0 means find a random unused port and use that. But then the more specific configuration says, I want to be on service port 8000 specifically. So this overrides what's in the application.properties. This is very convenient for having general purpose configuration and then very specific configuration. Now then, I've got this handy message, okay? So let's expose that as a REST endpoint in my code here. We'll just go back, and what I want to do is I want to inject the message and display it, okay? So I'll say value message, string message, Alt-Enter, and I'm going to say request mapping message, string get message, sure. I say return this dot message. And I want to be able to change this message live, okay? This is a silly example, but what we're going to do is we're going to make it so that whenever I change this message in the config server, I want to be able to redisplay the new value without restarting the application, okay? So I'm going to redeploy this component, and we should see that when I go to / message, it's going to print out hi, KC, and delicious barbecue, take 2, right? So localhost reservations is no longer there. It's on port 8000. There's my reservations, just like before. But now if I go to message, you'll see that I get that string that comes back from the config server. I want to trigger a change, so I'm going to go here to the reservation service. I'm going to say Atom, like this. This is the GitHub text editor. It's pretty legit. I'm a fan. And I'm going to say, Poland, okay. And then I'm going to git commit my change, right? So updated the message. Now if I go back to my config server, port 888, it knows of the change immediately, but my REST service does not, right? I want to change the REST service, which has that value, but I don't want to restart it, and I want to be able to do it in a central way. So the easiest way is if I go to my REST service, you'll recall that I added Spring Boot Starter Actuator. This is the set of metrics, management, health endpoints, things like that. When you have Spring Cloud, it also registers another endpoint called refresh. So what I can do is I can say curl -d, empty bracket means empty post, http localhost 8000/refresh. And what that's going to do is it's going to see that that I've changed the value here. This key is what changed in Git. And now when I go back to my code here, I can see the values there already, right? I didn't have to restart the app, right? Nothing has changed. I didn't have to change anything. What happened is that this controller got wrapped in a proxy, and then it was discarded whenever I trigger the refresh event that goes through and it finds all beans that have this annotation. I can connect my Spring Cloud microservices to an event bus based on RabbitMQ, and then send a message onto the RabbitMQ, and then every controller, every service connected to that event bus will refresh themselves automatically. So one message, you can reconfigure 1,000 services live, right, in flight. And the best part is, I'm doing this with it's a pretty simple example, but imagine instead a bean for a custom data source, like this, right? I'm going to say @value, my ds.url, whatever, right, string. Come on, Josh, you can do this. There we go. So, like, if I was doing that and I said @refresh scope up here, that would trigger a refresh of this bean. So all the code that injected a data source, including all the stuff that's using the data source, would get the new data source. They would not get a null pointer, it would just do the right thing. Now, that's one cross-cutting concern, okay? So this is just one. I think that's fine, but we should now build a service. We want to build a client to our reservation service. So we're going to go back to our start.spring.io, and the first thing we need when we start adding more services is the ability to make it easy for these services to discover each other. Again, if you're running these services in the cloud, and services come to life, if their services are constantly being started and stopped based on load and based on demand and capacity, you don't want them to be coupled to the actual host and port of these services. Additionally, you want a way to do something called client-side load balancing. Now, client-side load balancing gives you the ability to build services that can do routing in the client, as opposed to at the router or at the admin level for the actual DNS. And the reason you want to do that in the client is because you, as a client, are in a much better position to make a decision about why this client should do, what to do in the case of certain outages or so on. So for example, suppose I'm a client to my reservation service, and the reservation service goes offline, or the node I'm talking to goes offline. I want to be routed to the next one. Great. What about availability zone awareness? Suppose I have a service, and it's deployed on AWS, and I want to be able to route all my requests to that service in the availability zone that I care about. I don't want to call across the ocean when I could just call the ones near me. Again, that's very, very common. What about multi-tenancy? If I have, certain ranges of customers and they're all handled by these services over here and not those over there, again, that's a decision I want to make as a client to the service. It's not something I can program in my router very easily. So to support that use case, what you do is you use a service registry, and there are many options for service registries. We're going to use one called the Eureka service registry it's what Netflix uses, okay? By the way, Netflix, very, very big Spring Boot users. And now, if you come to our other conference, which isn't as cool as this one, but it's pretty okay, it's called Spring One, you'll see that they're actually using Spring Cloud. So this is a simple way to consume a lot of the Netflix bits that helps them scale. And again, they're using it. I think that's pretty cool. Imagine if Apple said, oh yeah, well, we have this API, but that guy uses our API and makes it even better, so we're going to use his code to talk to our own APIs. It's kind of what's happening here, right? So I'm going to say, give me a Eureka service. There are other options. In fact, there's console support and Zookeeper support, and there's a organization here called For Finance IT that's got a nice stand outside, and many of these contributors, many of the contributions that support integration with that kind of service registry come from For Finance. They're out there on the floor, so say hi. Eureka service, good stuff. And I'm going to hit generate again. This is going to act as a sort of phone book, okay? It's a way of asking questions about the state of the system. Where do these services live? Are there any available? How many, what are the host and ports? What are the capabilities, perhaps, right? You can use, again, any kind of service you want. If you're using console's written in Go, right? So you can't use Spring Boot to create your own console service. You just have to install it and then point your Spring Boot microservices or your Spring Cloud microservices to it. But since Eureka is written in Java, we're going to use that to actually install the Eureka service, okay? It's going to look pretty much the same as before. I also want to make it a Spring Cloud config client, so I'm going to do that. And I'm going to remove this. I'm going to open up application.properties, and I'm going to do what I did in bootstrap.properties on my reservation service. I'm going to say, great, Eureka service. And just as before, application.properties will be renamed to bootstrap.properties. And then I'm going to open up demo application, and I'll say @enable Eureka server, because I have to write some code, otherwise it's cheating. And here we go. So again, what I'm going to tell it to do is to get the configuration about where it lives and which port and all that stuff from the config repo. And we can see that that information says that it's going to start up on port 8761, okay? Localhost 8761, and there's my service registry, okay? This is console. This is a human wetware-friendly administrative view. There's also a REST API, and what we want to see as we're developing this app is that there's going to be applications registered here. So this is a human-friendly dashboard. You're also going to see, when we go back to IntelliJ, that there's a big, giant, huge stack trace in my console. And the reason is because Eureka's upset. It's unhappy with both me and you as people. Eureka is, after all, it's the beating heart of your service ecosystem. It's going to be used by services to discover each other and to find out where they live. If it goes down, you're in trouble, right? So it's important that you set this up in a highly available fashion. It's pretty dead simple to do, but in the meantime, it's going to throw lots and lots of exceptions and be very upset with us, and you might even see a big red error here in the dashboard. So let's see what the exception is. There it is. And it's going to say, where's my replica? Where? Null, right? So that's fine. We're going to let it be upset. It's still going to work. It's just one node, okay? Good, so now that's up and running. Let's go teach our reservation service about how to register with Eureka. Now again, Eureka is one service registry. Consul and Zookeeper are other service registries. If you think about what we're trying to do, we're just trying to figure out how to map service IDs to hosts and ports. So if you're running on a cloud like Cloud Foundry, which is open source, and Lattice, which is a distributed runtime for containerized workloads, those systems already know where these services live. So they can already answer the same question. With Eureka and with Consul and Zookeeper, the service, as it gets started, has to call the service registry and say, yeah, I'm here. Register me as being available on this host and port. But a cloud like Cloud Foundry or Lattice, they don't need to be registered. They already know. They started the app in the first place. In any case, no matter which implementation you're using, you'll have a discovery client API. It's the same API for all 5 different choices, and there's probably more coming. So you get a clean, consistent abstraction. So we're going to tell our reservation service to be a client to Eureka, okay? And then we're going to say @enable discovery client, and then we're going to restart. Carefully. Yes, I want to restart and stop and rerun. Drink some water. There's actually a more specific annotation that says @enable Eureka client. But again, this is just a meta annotation that is itself annotated with @enable discovery client. So if you just prefer to be generic and not care, then just say @enable discovery client and you get the same result. So our service is now up and running as we expect, right? So reservations, and within about 30 seconds or so, we'll see it get registered here in the dashboard. So we're going to give that some time. In the meantime, we're going to go. You can make the expiration time, by the way, smaller if you like, but for our purposes, we'll leave it alone. Oh, look, the console just said it's doing what it's doing. It's re-registering apps, registration service. So now if we go to here, we can see that it's registered itself, as reservation service, and that it lives on this host and port. You can't see the bottom left of my screen, but this is my host name on my local machine is JL, and on the left it says JL:8000 on the very bottom left corner of the screen. Okay, so there's one instance that's up. And if I wanted to go to it, I could click on that link and so on. So it knows where that service lives. And now I can, as a client, I can programmatically ask it, where does that service live? Let's build that client, okay? Let's build our first reservation client. We're going to say reservation service, reservation client. And I'm going to say that I want to be a config client, just like before. I want to use the Eureka support. I want to do a micro proxy using Zool. I want to have smart declarative interface and convention-centric clients or REST services using Feign. I'm going to use Hystrix to manage, to keep a sort of a stateful band-aid around my service calls, because again, something might go wrong and I want to have that support there. And then that's it, right? That's enough for now. I think that'll do. So, and I also want to have web support, because I can. And that'll do. Let's do this. Hit generate, reservation client, Command V. We're going to do a lot of things in here. So our service, the first thing we're going to do in our service is teach it where the config server live and teach it where the Eureka registry are. So just as before, we're going to take bootstrap.properties, Command A, Command C, Command V, and I'm going to go to this file in my reservation client right here, and I'll say rename this to bootstrap.properties. Okay? Again, all I'm trying to do is say that this is a client to the other service. I want to now demonstrate some progressively higher level ways to talk to that API, right? The first way, of course, is to just create a programmatic, or to use the Discovery Client API directly. So I'm going to say Discovery Client, I'm going to inject the Discovery Client abstraction, and I'm going to use that directly to call, to find out from the service registry where services live. So I'm going to say @enable discovery client, great. And I'll go down here and I'll say create a new command line runner. And again, the callback, the contract for this is I'm going to be registered when the application starts up. And when the application starts up, it's going to call this method. It's a callback interface. And it's going to pass in public static void main string arguments array. It's also a nice fit for lambdas. Okay, so I'm going to inject a reference to the Spring Cloud provided discovery client object. And I'm going to say dc.getInstances. And I'm going to say give me all of the service instances for the reservation service, okay? So this is get instances, and it's giving me a list of service instance objects back. And I'm going to say for each one that I get back, let's print out the host, the port, etc., and the service ID. So I'll say string, format, like so, and I'll say host and port, and then I'll say si.getServiceID, si.getHost, si.getPort, etc., okay? So that should be very, very simple. If we run this, we'll see the application should start up, and it'll find the configuration information from the reservation service. It's using the right, hopefully it's using the right Discovery Client implementation, because we've added the Spring Cloud Starter Eureka support. We added that jar. And there we go. We found that it's got one instance of that service that lives on this host and on that port. So that works, right? That is certainly good. I mean, that's a start. But we're not really getting the benefit of client-side load balancing. I still have to make the decision on which instance to use here. And plus, more often than not, I'm going to want to take that host and port and then pass it to a REST client, right? That's what I'm trying to do, is call another service via REST. So I'm going to create another command line runner. And in this command line runner, we're going to use the REST template, right? So how many of you know what the REST template is? REST template, awkward. So the REST template is a client that was introduced inside of Spring 3.0. It is a way of making REST calls from one service to another. And it's dead simple. It makes common HTTP invocations a one-liner, right? And the nice thing about it is that you can add interceptors. You can do gzip compression, you can do OAuth, authorization header intercepting, you can do all sorts of cool stuff. In our case, we're going to make it so that if we make a REST call and we give it a service ID, it's going to look that service up in the registry, find the first available instance that's useful, and then give us a valid host and port, and then call the service. When I say find the first available instance, I mean it's going to do software-defined load balancing, just like we talked about before. We want that choice about which node to use to be something that we can configure. And the way Netflix do this, and the way we're doing it, is to use something called Ribbon. Ribbon is a software-defined load balancer. It provides different algorithms that you can use to route your requests based on certain conditions or certain client-side use cases. In our case, we're going to settle for the default, which is just round-robin load balancing, okay? So I'm going to say return args, and I'm going to say rt.exchange, okay? And I'm going to say I want to make a call to HTTP reservation -service. Again, this is not a HTTP host and port. This is the service ID in the service registry. And that's going to be plucked out and then magically replaced with the correct host and port. We're going to make a GET request. We're going to pass in null, because we're not making a post, so there's no body to send. And then we need to tell our REST client which service to call, I mean, which data to return and how to return it. And this is where we kind of run into a kind of a problem with Java's generics. So Java generics, at runtime, Java does not know that an interface, or it doesn't know that an instance variable that has a generic argument, like a list of string, if you ask Java at runtime using reflection what the what the generic parameter for that list is, it doesn't know. That information gets washed away when you compile and run the code. That's erasure. You need to create a dynamic subclass. So if I said list of string x equals new array list of string parentheses, parentheses, curly bracket, like an anonymous inner class, that instance would have its generic information. So in order to tell our REST template to return a list of reservations, we need to pass in a parameterized type reference. Now, this brings up a kind of a sticky point. I need something it can return. Remember what I talked about earlier? In theory, and again, it's never been proven, but in theory, there are other technologies besides Java and Spring. So you cannot rely on having the server-side types for your client. Sure, I could in this case, but do I really want to? No. I want to keep myself decoupled from the structure of the service. So I'm going to create a client-side representation of the object that's going to be on the server, on the service. It's going to be the same kind of object. It's just I'm not going to have the JPA mapping annotations, and I'm not going to have any of that other stuff. I'll just do that, and I'll say another constructor, great, and I'll have toString. Okay, so there we go. So now I've got a local entity that is just going to, it's a POJO, nothing in particular. So what I'm going to say is I want to do a new parameterized type reference of list. What?
What is the command? Spring y or y on this non-empty constructor?
Sorry?
Non-argument constructor.
Yeah. I think that's the JSON mapping. It's going to map. So the question is, what is the no argument constructor for? You're right.
It's bad on the JPA and it's good in Spring, yes?
It's not Spring, man. Thanks, though. This is Jackson. So let's see. Spring actually can instantiate beans that have no argument constructors and regular argument constructors, no problem. It's easy to specify that. So okay, good. I'm going to return that anonymous instance variable, and I'm going to say to the REST template, give me a list of reservations back. So I'm going to say, give me the body, and I'm going to say for each record that I get back, I'm going to say R, and then I'm going to print out the information, just like we did last time. So I'm going to say pass in the R, and then print it out. And indeed, you know, this is kind of wasteful. I could just do this, right? Good. So there we go. We're going to get all the information back. And the nice thing about this approach is that you get to feel like you're working with a type system, but you're actually making a REST call, and you can, if you want, get the REST body that comes, the response entity that comes back from here, and check the instance variables and the status codes and the headers. And if you want to do that, that's great, but you also get the ability to deal with services pretty transparently, right? This is actually fairly minimal. I'm doing it all in one line, because I don't know why, no reason. If you did it in 2 lines, it's infinitely more readable. Good, so we're going to start that up, and we should see the same, we should see exactly what we expect, which is all the information coming from the service. So there it is, reservation ID 1, blah, 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 and then there's the reservation name, etc. Okay? So that works, and I actually kind of like this approach, but we can do better, right? We can go a little bit further. We can say interface reservation client, and what I want to do is I'm going to use feign to create a REST client by convention. Again, the previous approach gave me the benefit that I was using a type system, but I also could see the underlying HTTP calls. If I kind of want to ignore that altogether and move up a little bit higher in the abstraction hierarchy, I can do that here. So I'm going to say feign client, and I'm going to say feign, this is a Netflix project as well, call the reservation service, and then invoke the endpoint called, the URL, reservations, and use method, request method.get, okay? And that's going to be cool. And in order to turn that on, I have to say @enable feign clients, okay? So this is just going to turn on that support for me. And now I can build a third implementation of a command line runner that'll use feign. So I'll say feign client, feign or reservation client, okay, RC. And I'll say return args like so, rc.getReservations.forEach.system out print line. And now we'll see the same data twice. We'll see all the records from the service printed out using the REST template, and then printed out again using the feign client. And that'll be here. Cool. So there it is. There's 1, 2, 3, 4, 5, whatever. And then there it is again. And then, of course, there's my command line runner. Good. So now we have 3 different ways of doing the same thing. You can see that no matter what level of comfort you want to work in, you have that ability. And it's doing load balancing for you. So if there's one or many different instances, this will correctly handle that use case. What it won't handle is if there's 0 instances. That's the first thing we need to think about. And the other thing is that we also need to think about how we can act as a service that actual clients, like an iPad or an iPhone, can talk to, right? Netflix does this a lot, as you can imagine. They have 600 different microservices, each of which talks to each other. These are called mid-tier services, and so our reservation service would, in this case, be a mid-tier service. The client, on the other hand, for example, an iPhone or iPad, contacts the edge service, and this edge service talks to these mid-tier services and forwards the requests and maybe does some transformations and then returns a response. The reason they do this is because they have 600 different microservices and many, many different types of clients. iPhones, iPads, Xboxes, PlayStations, smart TVs, anything you can imagine, they have different clients. And these clients all have different kinds of security constraints. They all have different kinds of use cases. Some of them can handle more chatty protocols. Some of them can handle less. Either way, it's up to the edge service to transform or proxy or secure the calls from the client into the back end, right, into the mid-tier. So we're going to stand up. The first way to do this, the first way to handle this is just to maybe use a proxy, right? If you've been following, if you're up on your Ghostbusters mythology, right, Zool, then you know that this cutie pie, remember him? This is the gatekeeper from Ghostbusters. Anybody here know Ghostbusters? Yeah. This is Zool, the gatekeeper, right? And then this crazy person, is the keymaster, right? And the edge, this is our gateway service, right? This is a service that's going to forward requests to the other services. And for common cases, maybe I just need to proxy all of my mid-tier services to the client. Any HTML5 application, for example, will have this use case where they cannot talk to different services and different hosts and ports, and they don't want to change every backend or mid-tier service to have an origin policy that supports every new client, right? So they just create an edge service and proxy the request that way. So if I want to have that, this will do, right? This should be enough. So if I go to localhost, which port are we on right now, I wonder? Port. I think I'm on 8030, cat, reservation client, properties, 8050, right? So I'm going to say 8050, and if I want to call, my reservation service, I should just be able to say reservations, Oh, I didn't restart. Awkward. So you need to restart in order for that to work. Sad. There we go. And there's my back-end mid-tier, my mid-tier service. Again, I'm not calling the reservation service directly. I'm calling my edge service, and it's proxying the request to the reservation service. If I had a service in my registry called foo service, then this would forward the request to the foo service as well. So all of my mid-tier services are available here. This is fine for maybe common cases. You can secure this, you can add whatever you want, but maybe you want to do something more. Maybe you want to actually change the results that get sent back to the client. Perhaps you want to make it less chatty, perhaps you want to transform the results that get sent back, whatever. So we can actually do that as well. And we're going to demonstrate now how to make potentially unreliable service calls a little bit safer. So first thing we're going to do is create a REST controller. We're going to say class reservation names REST controller. Again, this is kind of a silly example, but it does, I hope, demonstrate the point, which is that we want to transform the information that we're getting back. And what I want to do is I want to call the backend service, but I want to have some smarts about what happens if that service isn't available. So I'm going to say reservation integration, and I'm going to say reservation integration, there you go. And I'll say at request mapping, and I'll say reservation underscore names or hyphen names. And what I'm going to do is I'm going to return a collection of strings, not the actual names themselves, right? So not the actual reservations themselves. I'll say reservation integration dot get reservation names, like so. And here we'll write some code to do that for us. Okay, great. I don't know. Create method get reservation names. Great. Here's this. And what that's going to do is this. Again, we're going to inject our feign client, in this case, reservation client. And I'll say return this dot reservation client dot get reservations dot stream dot map, and then for each reservation call reservation colon get reservation name, collect it. This is all just Java 8 awesomeness. Okay, so I'm going to say return a list of strings based on calling get reservation name from each collection entity that comes back. If I were making one or more calls right now, I would want to have that happen concurrently. And this is an amazingly good place to care about reactive programming. This is a great use case, for example, for something like RxJava. So I can make these two calls concurrently and then very cleanly and elegantly converge and zip, join the results back up and then send them back at the same time. Now, this will work, except, as we talked about earlier, in the situation where this client is trying to make a call to a service where there are 0 instances, right? One or more, this will work just fine. It'll round robin and it'll dispatch to the right endpoint. But if there are 0, then it's gonna fall apart. So what we want to do is have it do the right thing and gracefully degrade. So we're going to use something called the circuit breaker pattern. Okay? How many of you have ever read Michael Nygaard's amazing book, Release It, where he talks about the circuit breaker pattern? Amazing, amazing book if you get a chance. The idea is that I want to stop traffic. I want to stop something that might cause trouble from knocking down my entire system. It's an example of degrading gracefully. There's a guy named Fred George out of the UK who gives a great talk about this, and he compares the human body to a set of microservices. Or he compares microservices to the human body. He says, it would be absolutely crazy if you cut your finger and then you blue screened, right? It's nuts. And that's a great point. You want to have something that degrades gracefully. You want to do the right thing. Netflix does this a lot as well. They have a search engine, and maybe the search engine is down. And so they'll show recommendations from around the web instead. But they do something. They don't just throw an exception in the user's face. The goal here, remember, is to promote resilient services. Again, Netflix, for example, has 600 different microservices. You don't know, it's impossible to guarantee that you're going to have high availability for every service. Instead, they build software that is immune to failure, that is tolerant of failure. They embrace the fact that failure will happen, and they build software that is resilient to it. Google too, right? Google has 2 million servers, very, very beefy machines, all around data centers all around the world. 2 million of them. There are people that go to work every day at Google and just collect dead machines. That's their job. It's a fact of life. Things are going to break. They're going to die. Don't plan for one server to always be there, Adrian Cockcroft, former DevOps ninja and cloud guy at Netflix, he talks about this all the time. He says, treat your servers as cattle, not pets. They shouldn't have names, right? you should feel free to shoot it in the head and take it away. Not that you should do that to anything, but you know what I mean. So fallback method, we're going to say, when this method gets called and something goes wrong, call this other method, and it's going to be called fallback. And I'm just going to return collections.empty-list, great. And all that's going to do is it's going to do something, it's going to return nothing instead of an exception, right? And I'm going to say, in order to enable this circuit breaker, I'm going to go up to here, I'm going to say @enable circuit breaker. Fabulous, okay? And then that should do it, I think, right? So let's see if that goes. I'll drink some more water. And again, what this is going to do is it's going to, I'm going to make sure that if something happens and you make a call to this endpoint and it fails, it's going to throw an exception and this circuit is going to open up. No more electricity will be allowed to pass through it. That way you won't compound the problem. If you're trying to call a service and the service is down, you're just going to keep blocking. You're just going to keep blocking on a wasted effort. Why bother? Instead, route them to some sort of fallback thing and then try again later on. Maybe the service is up, but give the service a chance to breathe, to come back. Okay, so if I go to localhost, 50 now, reservation names, we'll see that service brings me just strings, right? That's my service. Great. And if I go to this, reservation service is working. What I'm going to do is I'm going to go to the reservation service right here, and I'm going to exit the reservation service, okay? So, do I have an exit in here? This is actually a hard stop. Oh, well, that's not great. I'm going to restart this as a process that I can actually exit correctly from, as opposed to brutally exit, just killing it. Run. Here we go. And that'll take a few seconds. And while that's coming back up, so I can show you that, we're going to get one more thing done so we can see what we're about to do. I'm going to create a dashboard, okay? So I'm going to go to start.spring.io. And when I come back, when that demo comes back, we'll do the demo, but then I'll show you that there's actually a circuit that's going to protect the traffic from getting out of hand. But I want to see where these circuits are. So I'm going to create a dashboard. I'm going to say Hystrix dashboard. And I'm going to go down to here. I'm going to say, give me the Hystrix dashboard. Great. Hit generate. And here's this. Command, show in Finder. Command V, Hystrix dashboard. Open. Now, let's see, is my service re-registered with Eureka? There's the client, there's the red arrow I was telling you about earlier. Reservation service seems to be re-registered. That's fine. Fine. Oops. So that's the empty array list, right? But the service, I just killed it, and it's going to come right back up. When it comes back up, you'll see that the names are there, right? So I killed the service. It's going to come back up, and it'll automatically it'll open the circuit. In order for me to visualize these circuits, I need a good dashboard. So that's what we're going to do here. Same as before, I'm going to say source main resources, bootstrap.properties. And I'm going to say open bootstrap.properties, Command A, Command V. I'll say, okay. Say @enable Hystrix dashboard. And then that should be it, right? That should be all I need. Hystrix dashboard, yep. Okay, and by the way, the reservation names are back, right? So the service came down, the data disappeared, it showed an empty array list. I brought the service back up. Now the data is there, great. In order to see all this happening, I want to actually launch my Hystrix dashboard and see, where the system is having trouble. Maybe an operator intervention is required, right? So this is very, very convenient. So this is started on port 8080, fantastic. Localhost 8080 /Hystrix.html. And there's my little endpoint. And what I'm going to do is I'm going to point it to a server-sent event-based stream that's being emitted by this circuit breaker on my servers on 8050, right? Again, if I have a dozen microservices, I want to aggregate these streams into one thing. And to do that, we would use something called turbine, right? That's this thing here, turbine and turbine AMQP. Turbine presents an aggregated stream, and turbine AMQP integrates it so that you can actually aggregate using RabbitMQ, for example, as a message bus, as a synchronization fabric. But in our case, we've just got one client, one service, so we're going to say, great, look at the server sent event stream from this one service and hit monitor. And I'm going to open this up, Command-Shift-M, I'm going to move that to the left, Command-Shift-M, move that to the right, and you'll see as I make requests on this service on the right, I'm making lots of requests, Command-R, Command-R, Command-R. You can see a moving average on the left of the traffic going into that circuit, get reservation names. As I stop, as I take my hands off the refresh, you see that the traffic drains off, right? And things are green, things are happy. The circuit is closed and traffic is successfully being routed through it. You can also see all sorts of other stuff like the mean, the median, the percentile, all that stuff. Now, let's go demonstrate what happens if we take the reservation service out of the game again. So this time, I'm going to exit, which is what I wanted to do. Right, so exit. And immediately, this is going to fail. And you can see on the left, it's closed now. Right? Or open, rather. So now on the left, it's blood red. Something is wrong. So I can visualize in one place what's happening and how this is happening. Okay, so what have we talked about? Not very much, a little bit. There's actually quite a bit more. What I'd love to do next time I see you, my friends, is to talk about single sign-on using Spring Security and Spring Cloud Security for OAuth. So you can say, here's a REST service. It's protected by this identity provider, either GitHub or Facebook, or you can use Spring Security OAuth as an identity provider as well, and then that can talk to any backend identity provider like Active Directory or LDAP or PAM or Kerberos or whatever. It's very simple. It's declarative. You say @enable OAuth resource. That's one thing that we haven't gotten to talk about here. Spring Cloud also provides Spring-centric integrations for a lot of the cool AWS. Oh yeah, a lot of the cool AWS APIs. So the SQS message queue is now exposed as a message listener container, very much like the RabbitMQ message listener container, or the JMS message listener container, or the Redis message listener container, or the, whatever, right? So a lot of different pieces there. And stuff that we don't even have, because this is all the GA stuff, but right now we've got cloud, console and Zookeeper stuff that's actually being set up. And some of the cool stuff that I will be able to talk to you about next year, but we're developing it right now, is moving to a messaging-based microservice model, right? So if you're doing stream processing, if you're doing big data, if you're doing continuous batch processing, you're not dealing with REST, you're dealing with events coming over a message bus. And you want to string together you want to coordinate lots of different services that are based on message queues. Kafka, for example. Netflix uses Kafka for billions of events every day. And Spring Integration and Spring Data and Spring XD, which, by the way, there's a talk on Spring XD this week, so definitely check that out, all support Kafka, for example, and RabbitMQ and whatever. So again, that kind of style of architecture is very, very, very powerful. You can get the same results by using Spring Integration today, but having it nicely integrated with Spring Cloud is something I look forward to. We also didn't get to talk about the cloud connectors, which are a little bit of decoupling between your injection and this infrastructure services, like your data sources, your Rabbit, your message queues, your emails and all that stuff, your send grids, etc. All these backing services that you may want to consume when you run inside of a cloud, a platform as a service like Heroku or Cloud Foundry or AWS or whatever. I think, my friends, that is it. That's a very small look at what's new and what's happening inside of this project. Again, Netflix and others are using it. Ticketmaster, how many of you have heard of Ticketmaster? Nobody? Oh well, they're a company. Oh yeah, they're a company in the States, and they $50 million every hour. All that, the entire service platform is based on Spring Boot and Spring Cloud. Big giant webs like Netflix that are basing on Spring Boot and Spring Cloud. So again, a lot. Whoops, wrong one. No. There we go. A lot of opportunity to scale here, a lot of opportunity to win. I hope it's clear from what we've just seen that this isn't a cloud. It's a set of tools for building apps that work well in the cloud. But as you saw, I just built everything on localhost, right? You can run this anywhere you want. The whole point is to build apps that scale well. And usually that means the cloud, but it doesn't mean you're locked into a cloud or anything like that. Dziękuję. Thank you so much, my friends.